Hi, welcome to Deuteron. In our product videos, we explain the important details of our product groups. I'm Alexander and happy to welcome you. This tutorial is about xanthan-based thickeners. The Deuteron company has xanthan-based thickeners in the product range. These products are suitable for water-based applications. In this video, we show you a short overview about the most important thickener types for Aqueous systems, the thickener variants of Deuteron, how they work, what has to be considered for the incorporation, and also some possible applications. The first differentiation can be made between inorganic and organic thickeners. Inorganic thickeners are, for example, silicas and clays, like silicium dioxide and aluminium silicates. Organic thickeners can be natural substances such as starch. Modified natural substances like cellulose products, for example, hydroxypropylcellulose, synthetic substances like so-called associative thickener, they have hydrophilic and hydrophobic parts similar to surfactants. These substances interact with the binder to create rheological effects. Polymers can be synthetic, for example polyacrylates or polyurethanes, or natural biopolymers like our xanthan-based products. They are polysaccharides, it means polysugars. This biopolymer is a fermentation product of the bacterium Xanthomonas campestris. Other polysaccharide biopolymers, such as cellulose, are modified natural substances. Xanthans form a network of tangled molecules by intermolecular associations between the polymer chains. Our Deuteron thickeners are exclusively based on xanthan and guar. The polysaccharides of xanthans are consisting of different glucose units. It looks something like this. Due to carboxyl groups on the side chains, the xanthan molecules are anionic. They can be called anionic heteropolysaccharides. Therefore, they are only compatible with anionic and non-ionic systems. In cationic formulations, incompatibility often occurs. This is usually unproblematic since most binders are anionically or non-ionically stabilized. As a food additive, xanthan gum has the E number E415 and guar gum E412. Now we come to the important parts. These substances swell in contact with water. Swelling does not occur in solvents. These aqueous preparations are not true solutions of the polymer in water, but a white mesh network, rather like wet cotton balls. This network influences the viscosity mechanically. This generates a jelly viscosity with strong shear thinning rheology. Shear thinning or structural viscosity means that the system has a high viscosity. The higher the shear force, the lower the viscosity. If the shear force decreases, the original viscosity builds up again. This figure shows that comparable viscosity levels behave completely differently under shear stress. For comparable base viscosity, different quantities are required. Cellulose needs 2.5 and our xanthan gums 0.75 or 1% for example. Cellulose thickeners do not generate structural viscosity, but only increase the viscosity in a linear way. Their viscosity hardly changes under shear forces. They are Newtonian liquids. The xanthan gum, on the other hand, rapidly decreases at high shear forces and increases the viscosity when the shear force is reduced. Xanthans have a high yield point. It means high shear stress is required to allow liquids to flow. If the shear stress is too low to overcome the yield point, no movement takes place. The system therefore remains stable. Deuteron VT930 at 1% increases the viscosity approximately 500 millipascal seconds under the same conditions of measurement. Stabilizing against sagging is easily possible. An example of this behavior can be shown with sand. While the cellulose does not really prevent the sand from settling, the xanthan preparation shows the effect of the structural viscosity. Without shear force, the viscosity remains high and settling does not occur. These effects are excellent for settling low levels of processing viscosity while maintaining high levels of stabilization. We have three different xanthan product groups: unmodified, chemically modified and mechanically modified. Our unmodified xanthans are Deuteron XG, Deuteron SR28, Deuteron VT920 and Deuteron VT930. Xanthans with chemically surface modification to prevent fast swelling are Deuteron VT819 and VT910. The mechanically modified xanthans are agglomerated powders. They also prevent fast swelling. These are Deuteron VT920 and VT930. Deuteron SR28 is a mixture of xanthan gum with guar gum, also a polysaccharide. Compared to pure xanthan gum, it leads to a higher basic viscosity, but may be disadvantageous in terms of pH stability. Deuteron VT855 and VT856 are pastes of Deuteron XG pre-wetted with water-soluble solvents. Pre-wetting enables an easy incorporation. Higher shear forces are only required for Deuteron XG and SR28. VT920 and VT930 need only slightly steering. Deuteron VT920 and VT930 are suitable for the use in food and pharma application. These different product characteristics are illustrated in the table on the last page of our product brochure. In principle, our xanthans can be used in all water-based applications. For example, food and cosmetics, detergents, drilling additives, explosives, and of course for us the most important application as thickener in any kind of water-based coatings, emulsion paints, plasters, wood stain, adhesives, pigment preparations and much more. Normally only small dosages are required, mostly in the range of 0.05 to 1%. The xanthan types without modification swell very quickly in contact with water. This can lead to the formation of lumps. To avoid this, slow addition at high speed is necessary. With increasing viscosity, the shear force should be lowered to avoid formation of stable air bubbles and foam. This is important for Deuteron XG and SR28. We offer modified types to avoid the difficult incorporation. Deuteron VT819 and VT910 have a small amount of glyoxal on the surface. Glyoxal delays the fast swelling. The water removes the glyoxal slowly. Homogeneous swelling occurs without lumps and without shear forces. The quasar granules of Deuteron VT920 and VT930 also delay swelling. Lump formation is also avoided. In this case, only slow steering is required. Here is a comparison of how the different pastes look. Deuteron VT930 is the only clear grade. For the incorporation of the glyoxal-coated grades, we have one more hint. The higher the pH value, the faster the swelling occurs. If the powders are stirred in at pH values below 7, they will be well distributed in the water. Then the pH value can be increased. Now the swelling occurs and the final viscosity will be achieved quickly. Xanthans are not compatible with alcohols. They will not swell in them, but they are relatively tolerant to alcohols in the formulation. For example, the xanthans are stable over a wide range against isopropanol, ethanol, methanol or acetone up to 40% without any adverse effects. The xanthan preparations are stable over a relatively wide pH value range. Of course, stability, especially over time, must be tested. Deuteron VT819 and VT910 have proven to be the types with the highest stability in our range at low pH values. The stability depends on the respective acid and all other components of the application. This has to be carefully checked. Xanthans are not sensitive against salt content like other thickener. The addition of salt can increase the viscosity, like here. There's a small effect on the viscosity with a small amount of salt. With a higher amount of salt, the viscosity decreases initially, but remains at a higher level. That means with salt content, the viscosity level can be higher. Overall, the stability of the system tends to be better. Also important, xanthans are biopolymers. Therefore, stabilization against microbial growth with suitable biocides or preservatives is required. Now we are almost finished with this product video. I will quickly summarize the xanthan properties and benefits. Xanthans are biopolymers of different sugars, called polysaccharides. Only low dosages are required, usually between 0.05 and 1%. They have a distinct shear thinning viscosity and high yield points. Therefore, a very good suspension behavior that prevents separation and settling. Xanthans are resistant to shear forces. The molecules are anionic, therefore they are compatible with non-ionic and anionic components. And they are stable against alcohols contents up to 40%, concentrated salt solution, high temperature and pH values, over a wide range in acidic and alkaline systems. They can stabilize emulsions and foams, and they are soluble in hot and cold water. They are easily pumpable and pourable solutions, but important, they need preservatives against biodegradation. Well, that's it for our xanthan-based thickeners. We hope this is helpful for you. If you have any further questions, please do not hesitate to contact us. Maybe we meet you in person soon at one of the next trade shows. And do not forget, our documents like product datasheets, safety datasheets and brochures are available in the download section on our website, completely free and without registration. Other documents, for example regulatory information, are available on request. We look forward to welcome you to our other product videos. Thank you for watching.